Hello friends, let's we start our new topic, that is memory chip. Memory basically is very important topic of microprocessor subject. It is the peripheral device that is used to store the data or the program that is being processed in any task. Let's see how the memory is being constructed. Basically, the basic element of any memory is the flip-flop. Flip-flop is a digital element that is used to store a 1 bit binary data. This 1 bit can be 0 or 1. As we have studied, there are four types of flip-flops are there, but in memory chip, mostly D-type flip-flop is being used because, as we know, D-type is a flip-flop that provides the output what is giving to the input. If we provide one input to it, then it provides one output. When we apply a clock signal, if we apply zero signal, zero input, then it provides a zero output. When we apply a clock to this flip-flop, means data flip-flop provides the output what is giving input to it. That's why it is used in memory chip. And if we connect more than one flip-flop in parallel, then they form a register. Thus we can say a register is a digital element that is used to store more than 1 bit binary data. If in any case we require to store more than 1 bit binary data, suppose it is 101, then to store these 3 bit binary data we require 3 flip-flops. And suppose there are 3 flip-flop, then first flip-flop will store 1, then second 0, then third 1. Thus we can say the combination of flip-flop is known as register. And if we connect more than one register, then they form a memory. Thus we can say memory is the combination of register and register is the combination of flip-flop. So if we internally see the structure of the memory, then it is just like a matrix form. Here 16 byte memory cell is shown. 16 byte means this memory structure have 16 register and each register is 8 bit long. Means each register is made by 8 flip-flop. B means byte. In this, the first register indicated by W0 and this first register had 8 flip-flops. Here are 8 flip-flops and this register can store 8-bit binary data. Similarly, there are 15 more registers, means this memory cell have total 16 registers, or we can say 16 memory locations, and each location can store 8-bit binary data. Thus we can say that this 16-bit memory can store total 16 into 8. There are 16 registers and each register is 8-bit wide. Thus we can say the total bit that can be stored in this memory chip is 16 into 8, means 8 means their total 128 bits can be stored in this memory chip. And to write the or to read the data from the memory, there is a control pin that is named as R/W bar. When we apply one signal to this pin, then read operation will be performed, and when we apply zero signal to this pin, then W bar means 0 ka bar means 1, means in this case W operation means write operation will be performed to the memory chip. And to activate the memory chip, there is a pin that is named as CS, and mostly it is CS bar, means it is also active low. When we apply 0 signal to this pin, then the memory chip will become active, and when memory chip become active, then the microprocessor can use any of the row of this memory chip, and the detailed structure can be understood by the given table. Here, this is a 4-byte memory chip, and this memory chip has 4 registers. 4 registers means this memory chip will have 4 rows: row 1, row 2, row 3, and row 4. And each the size of each row is B means byte. Means each row have 8 flip-flops. Means each row can store 8-bit binary data. Thus, this memory chip can store 4 into 8 means 32 binary bits. And in memory chip, in one time, only one row can be activated. Means microprocessor can read out of these 4 registers, but in one time can be executed only one register. And to activate the particular register, microprocessor generates the address of that register. In next lecture, we will discuss the detail about the address of the memory and how the microprocessor will generate the address to access the particular register of the memory chip. Thus, we can say this is a matrix structure. Here, there are 4 rows, and each row have 8 columns, and each cell represents one flip-flop. And in one time, only one row will be activated, and that row can be anyone, depends on the address generated by the microprocessor. So in next lecture we will discuss how the microprocessor access any of the register and how the data can be written or read from that register. Till that, I think you have understand the internal architecture of the memory. Means memory have more than one register, depends on the size of the register, and each register can store depending on the how many flip-flops are connected in that row. For example, let's we have a memory chip that size is 1B, or we can say let's we have a memory that have 1 GB capacity. 1 GB memory cell can have a total 1G register, and each register size is B means byte means one register can store 8-bit binary data, and this memory chip have 1G registers means 1G locations. Now you can calculate how many binary bits can be stored by this memory chip. It can store 1G into 8 means 1G means 2 power 30 into 8. You can calculate how much the data can be stored in a 1 GB memory cell. These are the details about the internal architecture of memory. Thank you for watching my video. If you found suitable for your study, then please subscribe my channel. Thank you.